Okay, so we saw that for this inelastic collision in the non-relativistic classical treatment, that the final velocity of the clumped particle is moving at half the speed as the initial particle because it has twice the mass. Okay. Um, Now we said that for an inelastic collision in the non-relativistic case, that the kinetic energy is not conserved. So let's check that. Okay. So the total initial energy, kinetic energy, which in this case is just 1/2 mv squared because the second particle is not moving, so it has no kinetic energy. So that's the total initial kinetic energy. And the total final kinetic energy um, is just 1/2 m prime v prime squared, which is equal to um, in the end 1/4 m v squared. V prime is equal to v over 2, m prime is equal to 2m, and so you get that the final kinetic energy is 1/4 mv squared. So we can see these two things do not agree, so they are not, it is not conserved, okay, at least in this case. Okay, so it's natural to ask where this energy went to. Where did this missing energy go? Well, remember, we're just considering kinetic energy here, and so the internal modes of energy, heat, rotation of the clump, deformations of the two particles or the clump, sound, these internal energy, this internal energy is not accounted for. And any kind of energy which we aren't measuring by, which is not represented in kinetic energy, is not accounted for in this kind of an elastic collision in the non-relativistic case. Okay, now in the relativistic treatment of collisions and decays, the total form momentum is conserved before and after the collision, and this includes the temporal term, what we've been calling the temporal term, which is the one that contains the energy, the total energy of the particle. So just to remind you, so the total initial form momentum is is conserved, so it's equal to the total final form momentum. Okay, and just remember that the form momentum is equal to the temporal component, which is actually has the energy term, and the relativistic 3 momentum. So this is the relativistic 3 momentum, and this is the total energy. Of a particle or system of particles, actually. Okay, so E over C is equal to gamma mc, as we saw in the last lecture, and the relativistic 3 momentum is just equal to gamma mv, where again gamma is equal to 1 minus beta squared. Okay? Okay, now the critical thing to realize is that all 4 components of the form momentum are conserved in a collision, in any kind of collision, no matter whether it's elastic or inelastic, including the energy component. And this is because the energy component is conserved because the internal energy is already accounted for via the mass. So the internal energy, basically, in the form momentum of a particle is just its mass times c squared.